So let's continue, and we are now looking at this question. Right, so what we've got here, we're asked to find the lengths of PA. We know that AB is 6. We know that BR is 4. Okay, and we know that SR, the height of this little wedge, is 2. So we're asked to find PA and AR. Okay, both of those are actually going to be hopefully reasonably straightforward to find. All right, PA is just going to be, if we look at this triangle on the side here, it's a right angled triangle. It looks something like this. Okay, something like that. This here is so we're trying to find PA. So we're looking at this, in fact, this sort of triangle on the side here. There's A, there's P, and there's Q, and we've got a right angled triangle, and we know that this is 2, and we know that this is 4. Right, that's 4 there, that's 6 there. Okay, so PA is actually going to be very straightforward. PA is just going to be the square root of 4 squared plus 2 squared. Okay, 4 squared plus 2 squared. So it's 4 squared plus 2 squared. It's in fact going to be the square root of 20. Right, if you type square root of 20 into your calculator will actually simplify it, because 4 is a perfect square, which square roots to 2, and we're left with 5 inside. Okay, but either answer would be fine. And then we also asked to find AR. Now AR is very straightforward, because if we're looking from the top, we've got a right angled triangle with a side of 6 and a side of 4, and we've got the hypotenuse. So in other words, AR would be the square root of 4 squared plus 6 squared. 4 squared is 16, 6 squared is 36. When we add 16 and 36, we get 52. Once again, 4 actually goes in there, and what's left is 13, and the 4 can come outside the square root sign to 2 root 13. Okay, then it asks us to find PAR. PAR. Now that angle there is actually kind of in the sort of 3 dimensions. Right. And once again, just like in the previous question, we've actually now got all 3 sides in this triangle. I'm going to show you the triangle for us now in the hopes that you can see it. It's kind of in at an angle here, but PA we know is 2 root 5, and this we know is 2 root 13. The triangle we're talking about is actually this triangle kind of here. It's a kind of sloping angle inside this block, sloping triangle. Okay, but it's not difficult to do, given that we now know 3 sides in this triangle. Right. So we worked out PR. Have we worked out PR? We haven't worked out PR, but PR is actually quite easy to work out, because it's the square root of 2 squared plus 6 squared. All right. PR is this side over here. PR is going to be the square root of 6 squared, because there's a right angle in there as well, plus 2 squared. Right, it's actually the square root of 40. Once again, the 4 can come out, and we get 2 square root 10. Okay, so this side over here is actually 2 root 10. Now the angle we're trying to find is there, and you may remember from previously this sort of rearranged form of the cos rule, and so I'm going to say it to you in words, right? But the cos, this is my answer to B, the cos of this angle PAR, just checking that we've got the right angle, yeah, we have, is going to be the two sides that make that angle squared. So in other words, we're going to take our 2 root 5. It's actually more helpful to take the square root of 20. And we're going to square that. And then the other side that makes that one, which is the square root 52, we're going to square that. Minus the one opposite the angle we're trying to find. Remember we said that that was actually 2 root 10, it's actually the square root of 40. So minus the square root of 40, also squared, all over twice the product of the two sides that make the angle, so not squared. So in other words, just that side times that side. Okay, so in other words, it's going to be, this one's root 20 and this one's root 52. Okay, and we can now go to a calculator and put all of that in. Okay, so there it is. I'm going to do the squaring of the square roots just in our heads. So that's just going to be 20 plus 52 minus 40. And on the bottom, we've got twice the square root of 20 times by the square root of 52. Okay, and we get that rather fancy looking number, which seems to be about 0.496. So cos of PAR is about 0.496. Cos of PAR is about 0.496. Okay, and therefore now to find PAR, we're going to shift cos, we're going to undo cos, we're going to find the inverse of the cos function. Right, let's see what that comes to. So we're going to undo cos, shift cos of our answer. All right, and there it is. It's about 60,3 degrees. It says 1 decimal place, so 60,3 degrees. Okay, a lot of this is just about being able to visualize in 3 dimensions. All right, it often helps to draw the separate triangles in 2 dimensions. Okay, the last thing here, it asks us, very similar to the previous question, it asks us now to find the area of that triangle. Okay, and that's going to be quite straightforward because the area of triangle PAR is just going to be half the product of 2 sides, okay, that make an angle. So it's going to be root 20, root 52. Times by the sine of the angle in between those 2 sides, so the sine of 60,3. Okay, and we can quickly bring up our calculator and see what that comes to. Okay, we've got the answer there, the angle there. Even if we press all clear, it's in the answer memory, so we don't need to store it anywhere else. We're going to go half, 0.5 times the square root of 20 times the square root of 52 times the sine of our answer. Right, and we press equals and we get 14. All right, so 14 is the area, okay, of that triangle. And let's just have a look at what our units are here. These units are, they're just units. Because it's an area, we would say 14 units squared. Okay. The next one is number 38. And what we've got is we've got a pyramid here. I've actually got a similar one over here, just as luck would have it. It's not quite, the one I've got over here is actually not exactly the same. The one I've got here has got a triangular base, right, rather than a square base. But it is very much the same idea. What we're looking for here is the height of the pyramid. Now the height is inside. It's not the slant height here. It's the height inside here. Okay, so let's see if we can make some sense of this. What we do know is, and you might want to pause the video and try this yourselves if you haven't tried it. We know that that's going to be a right angle there, right? And we've got all these lengths of x. These lengths of x are not only the sides of the base, but they're also the sides of the triangular sides. The triangular sides are equilateral triangles. Okay, so each of the faces is an equilateral triangle. So all the sides are x. Okay. Now, what if we look at this diagram and we drew a triangle from the side here? If we drew this triangle over here, okay, I was hoping to get a neater line than that. Let's just see if we can improve on that line. Okay. Okay, let's try that again. So if we go kind of across here, yeah, there we go, and we go come down here. Okay, so what we've got, this is P, this is Q, and this is F. And let's work out what we know. And we know that this is a right angle. And this is what we're trying to find. What we do know is that PF is x. So if we could work this out in terms of x, then we could use Pythagoras to get the height. So now we need to ask ourselves, well, what is QF? Okay, and so we're going to draw another picture. We're going to draw a picture looking right down from the top, because what we've got, the base is actually square. Okay. All right. And Q is right in the middle there. Now, if we just sort of draw a little picture here, because what we are wanting QF. We're wanting that distance there. Right. But what we do know is that that will be half, it's in the middle. So this will be half x. And this will also be half x. So can we work out QF? Yes, we can. QF squared, okay, I'm going to leave it squared. QF squared is going to be x over 2 squared plus x over 2 squared. Okay, so it's x squared over 4 plus another x squared over 4. It's actually 2x squared over 4. And that obviously simplifies to x squared over 2 if we divide the top and the bottom by 2. Sorry, x squared over 2. Okay, right. Now, this is x squared over 2. Okay, it's actually not x squared over 2, it's the square root of x squared over 2. Okay, because that's QF squared. I'm not even going to write that there on the diagram right now, okay, because we're going to make a little Pythagoras equation now. PQ squared will be PF squared minus QF squared. Okay, and I know that PF is x, so PF squared is going to be x squared. And here I've got QF squared. Notice I didn't ever need to actually get QF. All right, QF squared is x squared over 2. Okay, and that now PQ will be the square root of this answer. This can tidy up slightly because remember that this fraction is currently over 1. So if I wanted to combine these two, this would be 2x squared over 2 minus x squared over 2. It would actually just be 1x squared over 2. All right, and that would be PQ squared. And so to get the final answer, we would square root both sides. When we square root both sides, we're actually going to get the x can come outside of the square root sign and the square root of 2 on the bottom. Okay, and that will be the height of that pyramid in terms of x. Okay, we are going to ask you to try the next one before we next see you. Okay, but have a go and then we'll go over it next time.